This lesson is for section 9.3 on writing equations of ellipses. So our main objective for today is to write the equation of an ellipse based off of the given information. So real quick, I just want to review. The general equation for an ellipse is going to be of the form x minus h squared over the radius in the x direction squared plus y minus k squared over the radius in the y direction squared, and that will always equal 1. Now, in this particular problem here, the center is really easy to identify because we just take the opposites of what's in there. So we have 3 and -4. Now, for the vertices, we know that those vertices are going to have to lie on the major axis, and in this case, the major axis is in the y direction. So we see here that r sub y will equal 7. We just square root the 49 here to get r sub y, and r sub x is going to equal 4. Now, based off of this r sub y equaling 7, I can find the vertices just in my head. I know that this center here, okay, would be graphed in the middle of that ellipse, and then the vertices would lie above and below that. So if I want to translate a point above and below the center 3, -4, all I have to do is add 7 to -4 and subtract 7 from -4. So I end up with -11. That's the point that's below it. And the point above it would be at 3, 3. Now for the covertices, I'm going to do the same exact thing. This time I'm going to use the Rx here as 4. This time I'm going to add and subtract from the x value. That center here needs to be translated left and right. So for the point to the left here of that center, I would subtract 4. So I'm going to be at -1, -4. Notice that the y value here stays the exact same. To go to the right, I have to add 4. So I'm going to be at 7, -4. Now to find my foci, I have to find f first. So I'm going to solve the equation here. F squared is equal to the absolute value of rx squared minus ry squared. So if I just plug in here, I have 16 minus 49. Take the absolute value of that. You end up with 33. So f squared is equal to 33, which means f is equal to the square root of 33. So this is the focal distance. That's your focal radius. So I know that I'm going to translate the center, 3, -4. Again, this time it's going to go above and below because the foci have to lie on that major axis. So I'm going to take the point 3, -4, and I'm going to add and subtract root 33. Now you don't have to write it as two separate points. I will allow you guys to write it as plus or minus root 33, but make sure that you realize these are two distinct points, okay? Okay, up next, in each of the 4 problems below, we are going to write the equation here in standard form. So we're going to complete the square very similarly to what we did with the circles, but now we're finding that these equations will result in ellipses. Now, the fact that we're saying that it's an ellipse actually helps us a lot. It guides us and lets us know what general form our equation should end up being in. Eventually, as we get to know and learn more conic sections, you will have to be able to identify the type of conic section off of the equation. So we won't give you hints. It'll just say write the equation in standard form and then graph the picture. So in this case, we start off kind of easy because we're telling you what the shape is. So let's go ahead and start right away with number 1. Now, this is clearly not in the standard form because on the right-hand side here, we need this to equal 1. So this one's a pretty simple one. We're just going to divide everything throughout so that we can get 1 on this side. In other words, I'm going to divide the entire equation by 12 so that I end up with 1 on the right-hand side. Now, if I divide 12, this term here turns into y squared over 1. And this term here, if I divide that by 12, that turns into x squared over 4. So right away, I've already turned this into its standard form. I have x squared divided by 4 plus y squared divided by 1 equaling 1. In other words, rx will equal 2 and r sub y would equal 1 here. Now notice we didn't have to complete the square whatsoever here. And the reason we didn't have to complete the square is because we don't see an x term. Okay, there's no just x term on its own, there's no y term on its own. We only have an x squared and a y squared term. The same thing goes for number 2 here. And in number 2, if I want to get the right hand side to equal 1, I'm just going to divide everything throughout by 50. So now I have 1 on the right hand side. On the left hand side, 50x squared divided by 50 gives me x squared. And 2y squared divided by 50, well, that's going to give me y squared over 25. So I'm just simplifying 2y squared over 50 as y squared over 25. Now, in this case, since I had x squared, I'm going to write that as over 1. Okay, so it's more like the standard form for an ellipse. And then from here you can see that Rx is going to equal 1 and R sub y will equal 5. So this time the ellipse would be elongated in the y direction, and over here that ellipse would have been elongated in the x direction. Okay, now question 3 is pretty similar to the type of questions that you saw when we were writing the equations of circles in standard form. Now the only difference is that instead of having just x squared and y squared, now we have a coefficient in front of the x and in front of the y, okay? We still see that we have an x term and a y term, and the constant's already been moved over to the right hand side in this case. So the reason why this problem is going to be different than questions 1 and 2 is because we have these terms here, okay? So we're going to have to complete the square here as soon as we notice that we have linear terms. Okay, now what I'm going to do is group those x terms together. So I have 16x squared plus 32x. I'm going to leave myself some space here. Actually, we have to do something special before we even leave ourselves space. And then we have 4y squared minus 8y. And again, I'm going to leave some space here, and then equals 44. Now, that special thing that we have to do before we even complete the square here, I'm going to factor out of these two terms here a 16. I do not factor out the actual x term, even though they both have an x in common. I'm only going to factor out the coefficient in front of the x squared and the y squared term. That's really important. It's just the coefficient. Once I factor out that coefficient, now I have x squared plus 2x on the inside here. So if I complete this square here, I'm going to divide 2 in half, so I get 1, and then I square that, so I get 1, okay? Now on the right hand side, remember how we're always paranoid about making sure that we we balance the equation? Well, if we just write plus 1 on the right hand side here, we're not actually balancing the equation, because if you look over on the left, what we're actually adding to the left hand side here is 16 times 1, not just 1, 16 times 1. So over on the right hand side, I actually have to add 16. So one of the biggest mistakes that students will make is they only add this value to the right hand side. They forget to actually multiply that out in front here. So we're adding 16 to the left hand side, so we have to compensate by adding 16 on the right. Now I complete that same process here. I'm going to factor out just the lead coefficient in front of that y squared term. So I have plus 4, then left over on the inside would be y squared minus 2y, and then I'm going to leave myself a nice little blank here, okay, to complete the square. So I cut that negative 2 in half and I square it. When I do that, I end up with, again, a positive 1. So be careful that you don't just add 1 over here. It's the same reasoning here. We're going to have to multiply it by 4. We're really adding a 4 to the left, which means we have to add 4 to the right hand side of this equation. Okay, the whole point of this is so that we can write this as a perfect square. So the fact that we just created a perfect square means we can now factor it into x plus 1 squared. Okay, so we have 16 out in front, then x plus 1 squared. Then we have a plus, let's do this in blue so I keep the colors consistent, plus 4 times y minus 1 squared. So the factoring here, this turns into y minus 1 squared. So just be careful that you don't factor it incorrectly. Now, let's make sure we add up the constants here on the right-hand side correctly. So we have 16 plus 4 is 20, plus 44 gives me 64. Okay, so this is pretty close to being in standard form. I know it doesn't look like it yet, but basically all we have to do now is get this right-hand side to equal 1. So remember, to get that to equal 1, all I have to do is divide the entire equation by 64. So on the right-hand side, 64 divided by 64 gives me 1. Now when I divide these terms here by 64, the x plus 1 squared does not get affected. I'm just going to reduce 16 divided by 64. So in other words here, let me show you what we're trying to do. We're trying to simplify this. So as you can see, 16 over 64, well that becomes x plus 1 squared over 4. So let me rewrite this as x plus 1 squared over 4. Now the second term here, I just like switching colors. I'm going to do this in orange. The second term here, we're going to take 4 times 1 minus y squared. Or did I say 1 minus y? Sorry. Y minus 1 squared, divide that by 64. So we get y minus 1, that quantity, squared over 16. So I'm just simplifying here, okay? So right now, that's in standard form. This is an ellipse. And as you can see here, the Rx would be 2, the Ry would be 4. Okay, let's see if we can go a little bit faster here in number 4. So right away, I want to rearrange this so that I have the x squared and the x term coming out here first. So I have 2x squared plus 16x, and then plus y squared minus 12y Then I'm going to add that 10 over to the other side. Now I didn't leave myself space yet because I know that I still have to factor out the coefficient in front of the x squared term here. Now the coefficient in front of the y squared term is already 1, so you don't have to factor anything out. So I'm going to factor out a 2 from these two terms here. So if I factor out that 2, I have x squared plus 8x. Now I'll leave myself a space. Okay, I'm going to put parentheses around that. And then over here I have y squared. Again, I don't have to factor anything out of this. Minus 12y, and then I'll leave myself another space here, equaling 10. Now let's complete the square. So we're going to cut that number in half and square it, so we get 4 squared, which is 16. Now on the other hand side, make sure on the right that you're not just adding 16, you have to add 16 times 2. So we're adding 32 to the right hand side. Now for this term here, we cut that in half and we square it, so we get a positive 36. Remember, these terms here should always be positive, even if that sign here is negative, because when you square that negative 6, you get a positive 36. All right, so here, because we don't have any multiple on the outside of this trinomial here, right, there's nothing on the outside that we factored. In this case, we can just simply add 36 to the right-hand side. Okay, so let's now rewrite this as 2 times x plus 4 squared. So we're just factoring this trinomial here and writing it as a perfect square. And then we have plus y minus 6 squared, equaling, on the right-hand side, this is going to be 78. All right, one last step now to make sure that it's in the standard form for an ellipse. On the right-hand side, we need this to equal 1. So we're going to divide everything throughout by 78. Okay, so we're taking everything and dividing it by 78. You might want to just do that anyhow. I know I wrote it as one big fraction bar, but it looks a little bit cleaner anyhow when you write it underneath each term. So anyhow, on the right-hand side here, we'll get positive 1. On the left term over here, when you simplify 2 over 78, you're going to get x plus 4, that quantity squared, over 39, and then plus y minus 6 squared over 78. This isn't going to simplify any further. Now, some people have a hard time with this one because they think that these numbers here must always be perfect squares, but they don't have to be perfect squares. In this case, r sub x would just be kind of an irrational number here, root 39, and r sub y is going to be the square root of 78. So they're not pretty numbers, but that's okay to have a number that's not necessarily a perfect square. Okay, we finish off this lesson by having to come up with our own equation for an ellipse based off of some characteristics of an ellipse. So rather than manipulating an existing equation by completing the square, we actually have to come up with an entirely new one on our own. Now this is going to make me sound super nerdy, and I'm fine with that because I am, but basically I love these problems. They're really challenging, they really force you to think, and I think they're the most fun thing that we do all year in algebra. So basically I love these problems and you should too. Now it's important to mention though that these are pretty tough for students at first, and then finally once you start getting the hang of them, I think they become easy just like every other skill. But basically at first it's going to be tough because you have to do so much thinking in these problems. Okay, so if you're confused at any point, trust me, that's natural. Just make sure you replay certain parts and then you come into class tomorrow ready to ask good specific questions. All right, so let's start with number 7. It says the foci are at 5, 0 and negative 5, 0. The vertices are at 9, 0 and negative 9, 0. Now based off of this, we're supposed to be able to fill in x minus h, that quantity squared, over r sub x squared plus y minus k squared over r sub y squared. And that, of course, will always equal 1. So based off of this limited information, we're supposed to be able to fill in all of the parts for this general equation. Okay, so right away we notice we don't have a center, so we can't plug in hk yet, right? We also don't have rx or ry. They don't just tell us those values, so we're going to have to figure them out on our own by doing some serious thinking here. Now let's look at the fact that they list the foci. The foci are at 5, 0 and negative 5, 0. Remember, foci are always listed on the major axis, so right now these points, negative 5, 0 and 5, 0, if you just visualize these lie on the x-axis, which means that your major axis is in the x direction. So this number for sure is going to be bigger, okay, than r sub y squared. Now, in this case, to find the center, it's really pretty basic. You're just going to find the midpoint of these 2 points. And that's something that, like I said, I want you to be able to do this in your head. So you're just averaging the distance between the x values. So you add 5 and negative 5, you get 0 divided by 2, and you still get 0. So our center for the x coordinate is going to be at 0, and then if we do the same thing for the y's, we add them together and divide by 2, we get 0 as well. So the center here is at 0, 0. Now we can fill in that part for the h comma k. If you want, you can write x minus 0 squared, or you can just leave it as x squared, okay, over some number plus y squared over some number equaling 1. So all we have left now is to figure out rx and ry. All right, so let's use the fact that they give you the vertices here. So remember, vertices have to also lie on the major axis. So we're at 9, 0, and negative 9, 0. It does help to draw a little picture. That's why I'm drawing this here with you. I want you to get used to these kind of strategies, because don't try to do everything in your head, because drawing the picture at least gives you a foundation for where to start. So anyhow, those vertices are at 9, 0, and negative 9, 0. Remember, r sub x, that is the distance in the x direction from the center of the ellipse to the ellipse. So this value here is r sub x. We know that if the center is at 0, 0 and an endpoint here is at 9, 0, then r sub x has to equal 9. So we have 81. That's what we'll place underneath that x squared term because we want to square 9. Okay, so r sub x, let me write this off to the side. R sub x here is equal to 9. All right, now let's see if we can try to figure out r sub y. Now this one's going to be much trickier, okay? The reason why it's trickier is because they don't tell you where the co-vertices are, right? They don't tell you explicitly where that is, so we can't just figure out what r sub y is. In this case, what we're going to have to do is rely on the fact that they give you the foci here, okay? It actually relates back to the foci. I know that's kind of weird, but anytime you're given foci, you're going to have to use that formula, f squared is equal to the absolute value of r sub x squared minus r sub y squared. So this relates for you the r sub x, the r sub y, and your focal radius. Okay, so if I'm asking you to solve this equation here, that means then that you should be able to tell me what r sub x squared and f squared is. Now r sub x squared, that's easy, right? We already know that that's 81. Okay, but solving for f squared, that's a little bit trickier. In this case, if we go back to where those distances, where those points are from the center, this distance here represents f. It's the distance between your center and your focus. So in this case, that distance is 5 units, right? Because we go left 5 and we go right 5 to get to those foci. So in this case, f squared here is 25. Again, if you're ever given foci, you will always have to use somehow this particular formula in finding the equation for your ellipse. Okay, so all we have left to do is solve this equation for ry squared. Now, in this case, I know that we have this absolute value bar here, but we're going to drop the absolute value bars only because we already know that ry squared is supposed to be positive. Okay, so if I solve for that and I subtract 81 on both sides, I'm kind of pretending like those absolute value bars aren't even there. I end up with negative 56 equaling negative r sub y squared. So obviously if I solve for r sub y squared, I do get positive 56. Okay, so if I come back now to that general equation here, I'm going to substitute in for r sub y squared a value of 56. So this here is now the standard form, okay, the general equation for that ellipse. Okay, here number 8, we're given totally different information. This time we're given the endpoints of the major axis as well as the endpoints of the minor axis, which means they're telling you the vertices as well as the co-vertices. So if I look at the first line here where it tells me the endpoints of the major axis, if I were to graph these, just real quick, a rough sketch of this, I have a point at 4, 2 and a point at 4, negative 8. Now I notice that these points lie on top of one another, which means then that the major axis is elongated in the y direction. So r sub y, that should be a bigger value than r sub x, okay? Now really all I have to do is find the center so that I can start plugging some stuff into this particular equation here. So if I find the center, all I need to do is average the distance. It's just the midpoint of these two points here. So I'm just averaging the x values and I'm averaging the y values. Well, my x value has to stay the same, right? If I'm going to have a midpoint in between there, the x value, that coordinate must stay the same. Now the y coordinate though, to find that, I'm going to add 2 and negative 8 and cut that in half, so I get negative 3. So my center here is at 4, negative 3. Now let's just plug that in real quick. So I have x plus 4 squared over some value plus y plus 3 squared over some value equaling 1. Now if you notice the points that they give you for the minor axis, see how the y values are at negative 3 And notice how the center had a y value of -3. That also will make a lot of sense if you just kind of draw out this sketch. You have a point at 1, -3 and at 7, -3. I know this isn't really drawn to scale, but basically that has to share the exact same y value as your center. So you can easily spot the center actually just by looking for the endpoints of the major axis are at 4, and then the end for the x value, and then the endpoints of the minor axis share the same y value. So your center has to share that same x and that same y value here at 4, -3. Okay, all we have left to do now is to find r sub x and r sub y. This time we don't have to use that equation f squared is equal to r sub x squared minus r sub y squared. The reason we don't need this is because they don't tell us any foci, so we don't need to use this equation. So don't overcomplicate a problem. In this case, because we have the center and we have the endpoints of the major axis and the endpoints of the minor axis, that means we can find r sub x, which is this segment length here, okay? We can also find r sub y, which is this segment length here. Okay, so I want to mention here that the length of that major axis is not equal to the length of r sub y. R sub y is only half of the length of the major axis. Now, in order to find r sub y, we need to figure out the entire length of the major axis because we give these endpoints here. So we can find this entire length and then we'll have to just cut it in half, okay? So if we look at the distance between 4, 2 and 4, -8, we would use distance down here. We're going to square the difference between the x values. The difference between 4 and 4 is 0, so we square that. Then we find the difference between 2 and -8, that's 10, so we'll square that value. Once we take the square root here of 100 on the inside, we get 10. So the whole distance here is 10 units long, which means that r sub y, this value here, is only 5 units long. So one of the common mistakes that I'll see is that students will just cut that and they forget to cut it in half and they put 10 squared here as opposed to 5 squared. So we're using r sub y, in this case, is 5. So I square 5 and I get 25. Now for r sub x, I'm going to do the same exact thing. I want to find the distance between these 2 points now. So let me erase a bunch of stuff here. Actually, I don't want to erase because I want you to be able to see that work. Okay, so over here I'm going to find r sub x. Now to find that, I need to find the total distance for that minor axis here. So I'm looking at the points 1, -3 and 7, -3. So if I take the square root and I look at the difference in the x values, the difference here is 6, and I square that. Then I take the difference of the y values, which is going to be 0, and I square that. I end up with the square root of 36. So the minor axis length, the entire thing, is 6 units long. When I look for r sub x, remember there's your center, r sub x is only the distance from the center to the ellipse. So here is that value. Oh, sorry, it's not 6, duh, I have to cut it in half. It's 3. Okay, so r sub x here is going to be 3. So when I plug that into the general equation here, I have to square that value and I get 9. So there's lots of little areas where you can make mistakes. But if you're perfect on this, like if you can execute this problem by thinking through it really clearly, that's what I think makes them fun. But then you shouldn't have a problem with it. If you aren't so good with what r sub x means or r sub y or any of the little minor details, it's very apparent when you try to write equations that you'll have a hard time. Okay, so all right, let's try a couple more and then it'll be the end of the lesson. Okay, in the interest of keeping this video a little shorter, I'm going to do number 9 with you, and I'm going to make you guys try number 10 on your own, so make sure you do check the key for that problem. Okay, for number 9, we are given the center, so that's kind of nice. We can already fill in x plus 4, that quantity squared, plus y minus 2 squared, and then all we have left to do is find the denominators for both of those terms, and then equals 1. Okay, so here they give us the foci, right? Which means that we will definitely, for sure, be using this formula. R f squared is equal to r sub x squared minus r sub y squared. So at some point, that's going to have to come into play. But first, let's just talk about what that tells us if the foci are located at -4, 10 and -4, -6. Now, if I draw a little sketch here, -4, 10 and -4, 6 are something like this, right? Notice that the points lie on top of each other, which means that r sub y is going to be the bigger value. Okay, r sub y is half of that distance here, but that's definitely the bigger value because your major axis means that your your ellipse is elongated in the y direction. Okay, now here they say that the length of your minor axis is 12. So if we think about that, that minor axis has to go across in the x direction, right? And the length, the entire length, is going to be equal to 12, which means r sub x, because remember it's only half, r sub x is going to be 6. It's going to be exactly half of that entire length of the minor axis. So underneath this x plus 4 squared, let's not put just a 6. Remember, we have to square that value. Some people will forget to square it, so just be careful about that. We should square 6 and we get 36 underneath the x plus 4 squared term. We cannot put it underneath here because that is not the larger of the two values. Okay, now to find this value r sub y, like I said, we'll have to rely on this equation. Now in this equation we already know that r sub x squared is 36, so I'm just going to plug that in. So I'm taking 36 minus some r sub y squared, and that's supposed to equal f squared. Now this value f, we can find that. We already know that the center is at negative 4, 2, and we have both foci listed. So if we were to plot this, let me do this on a number line to make it a little bit easier. So I have the point negative 4, 2, and I have a point up here at negative 4, 10. I have a point down here at negative 4, negative 6. Now f, remember, is the focal radius, the focal distance. It's the distance from the center to your foci. So here, let's label those as f1, f2. So this value here is f, okay? Now if you look at the distance, we're just going to look at the change in the y. This distance is 8 units long. Same thing goes with this. This is 8 units long. So that should match up. You should always get the same exact value because the distance from the center to both foci has to be the same. Those both values here are 8. Okay, so that does help us because in this case we can just plug in 8 for f and we get 8 squared. So we have 64 is equal to the absolute value of 36 minus r sub y squared. All right, now we didn't run into this problem in the last problem, and that's because the r sub y in the last problem was already smaller. It was supposed to be smaller than the r sub x. Now in this case, r sub y is supposed to be bigger. So if we just drop the absolute value bars and we try to solve, we end up with 28 equaling negative r sub y squared. And obviously here, we can't have a negative value for r sub y, but it doesn't even make sense if you try to plug that value anyways back in. If you plug in 28, even if you made it positive, 36 minus 28 does not give you 64. So in this case, I should have mentioned this to you earlier, and I apologize that I didn't because hopefully you're not tuning out. But this portion here, you should always be taking the larger value and subtracting away the smaller value. That way you guarantee that you're going to get the correct answer here. So if I do that, if I guarantee that I'm taking the larger value minus the smaller value, I don't have to worry about absolute value whatsoever. So in this case, if I solve here for r sub y squared, I would add 36, and I get 100 equals r sub y squared. So r sub y is 10, but I don't have to plug that 10 in. I have to plug in 100, right, into that equation here. So I have y minus 2 squared over 100. So this is the general form, the standard form, I should say, of this ellipse. Okay, so that's the end of the lesson. Now, I have a feeling that when I was explaining this whole absolute value business, that I'm probably confusing a ton of you, and I apologize for that. My intention is obviously not to confuse you. It's to try to clarify things for you, if anything. So I just want to real quickly summarize what I meant about dropping the absolute value bars here. Okay, so we ran into a problem, obviously, when we just dropped the absolute value bars and we tried to solve for r sub y squared. We ended up with a negative value for r sub y, right? Because we ended up with negative r sub y squared equals positive 28. If you solve that all the way, you would get negative 28. Clearly, that can't be the case. Now, what you can do to ensure that that doesn't happen is you could write the inside of this, okay, here, so that the larger term always comes first. Now in this case, r sub y squared has to be bigger because we know that that's on the major axis, right? It's elongated in the y direction, so r sub y squared must always be bigger than 36, the rx squared. So as long as you write it in this form, you won't get an incorrect answer if you drop those absolute value bars, okay? So that's kind of what I was trying to summarize for you. So to keep it safe, if you always write, when you write out when you write out that f squared equaling the absolute value of whatever's on the inside, when you write this out, if you write the bigger number first and subtract the littler one from it, you won't ever have an issue with what I was just messing you up with over here, okay? All right, so that, for real, is the end of the lesson. Nice job. I will see you guys in class tomorrow.